a simple smart contract, and we're going to test. We're going to show interacting with it on the, not on the main net, but on the Go Ethereum simulated backend, which we could use for a testing environment. We'll use a mixture of the stuff that's already there and a couple of libraries which are in some of my articles, which we can post in the comments to the video when the video is posted. Right?
Should they follow together, or because some
probably
people already opened their text editor here?
Well, okay. Yeah. If you've got Go installed, please do.
Yeah, no, I don't have Go installed.
This is when I always catch
Yeah,
people
but
out.
we don't. Yeah.
Okay, let's start with a very simple contract then. So who's written smart contracts before? Hands in the air.
Never? Yes.
Ever? You done it? Yeah. Cool.
Not yet.
Not yet. Okay. First line of every smart contract telling it the minimum version of the compiler, because the language keeps evolving and you don't want to throw next year's code into last year's compiler. Right? This is much like a class statement in many languages. You're defining what it is we're creating with contract. Give me a name for a contract.
Can you zoom your editor a bit?
Can I zoom my editor? I probably could do. Like that?
A bit more?
A bit more. Oh my god.
Okay.
Okay, then I shall try and lose that for a bit. Contract. Come on, give me a name. Contract. Test. Thank you very much. Right. And so, the briefest of introductions. It's like a class in C++ or Java, or does JavaScript have classes? It does, doesn't it?
Yeah, it does have.
Yeah, I attended a couple. Never mind. It's a strongly typed language, unlike certain other languages, right? So you have to declare the type of the variable, and we'll public. So we're going to create a public variable. And if it's public, you have to say that it is public. And if you're going to call it that, you might as well spell it right. And function set my variable uint new value, and we put my public variable equals new value. Oh, and we need to put visibility on that as well. Right. So what we have now is something really simple. We have a contract. It has a single variable which we can set. You can read the value because it is public. In a smart contract, if a variable is public, then you automatically get what's known as a getter. In other words, a function that allows you to read it. It is also very good practice to use events to allow you to monitor something from the outside without actually watching it. So event value set uint new value, right? In which case now I can put in here emit value set new value, like that. And of course the fact I called it new value both here and here is totally irrelevant. Yeah, we know that. Right. So what we have now is a contract. It's a very stupid simple contract, right? All we can do is we can just keep on going in and setting the value. Let me do one more thing. Sorry. Uint date. Because what I'm going to do here is do that. This really upsets the editor, which doesn't like using now. But anyway, so what we're going to do is we're going to emit this with a timestamp on it, just for fun, right?
So now relates to the time that
Now,
the
okay,
transaction...
so being a blockchain, it doesn't know when you submit it. It's the time that it's basically the block timestamp, right? And it's giving you a warning. There you go. It tells you that it's an alias to block timestamp. It tells you to avoid using it because people started using it for inappropriate things, like trying to get random numbers and stuff like that, which is totally inappropriate. But it's perfectly legitimate to use it as an indication of when the thing was included in the block. Right, so you can use it for begin and end times for contracts and things like that. Okay, so if we have that, now we can go into the contracts folder, and if you've been following the game so far, you know you should be able to compile that. Right, I didn't ask it for an output. Yeah. So it compiles. Yes.
To give you an idea, why not we do this on Remix so that they can try on their browser?
Well, you can do because we're not doing it to test the smart contract. We're doing it to show it inside.
You need to
Inside Go.
Okay.
Oh,
I do have. You have Go.
Yeah. You have. Oh my God, you foolish person! You will now have to include an awful lot of crazy stuff in there. Right. Okay. But that's not what we're going to do. Right. What we're going to do is we're going to use something called ABIGEN to create a wrapper around it in Go so that your backend can interact with the contract. Right? A lot of what you do uses JavaScript to interact with contracts, and the big reason for that is that normally you do not want to be trusting anybody else's computer. Right? So like you want to sign a transaction, you don't want to send your private keys to someone's computer to sign a transaction because you don't want anyone else to get your private keys. That would be silly. But sometimes you can have servers doing things, right? Servers can set information. That's how oracles are written, for example. Right? So this is where we're coming from here. So if we're going to do that, we run ABIGEN. Right, so here we take the input, the Solidity file, test.sol. You can also work with an ABI file, which is just the interface, to interact with a contract that already exists. We create a Go package called test, and we're going to write it to test.go. In fact, no, we're not. We're going to create a package called, silly me, contracts. Which will make sense in a minute. Right, and you will see that has automatically created test.go. It says it's generated, do not edit it. And this allows you to wrap your contract. You can interact with it from a Go program. Right, at which point we will now close that. And we are going to now deploy this contract. We'll look at deploying it on anything, but then we'll stick to the simulated backend because it will make my life easy.
Other than Go, can we do the same thing using other language?
Yeah, Java.
Java.
Mm-hmm.
Yeah, asking for others.
Yeah, you don't need it. You don't need it for. I don't think you can do a C++. Sorry, C# rather.
Can you do in JavaScript?
No, you don't need it in JavaScript because in JavaScript you use Web3 and Web3 would take the ABI to interact with it directly.
Like a REPL or something. Right.
Yeah, I mean, because JavaScript is kind of naughty in the way it does everything. Okay. So a classic Go program. Package main, function main. There we go. We have a Go program. Now we need to start interacting with this thing. Right. We need to talk to the simulated backend. Right? Or we're going to create the simulated backend.
There's another.
Most of what I'm doing here can also be used to talk to the live net or a test net or anything else. It's just the connection part, right? Base client, which is a star. There we go. And being Go, of course, it really nicely imports everything as we go along. Right. And this is going to return me a client, which is one of them. Does it really? Yeah. And then no, yeah, that's right. Right. Okay, so a simulated backend. Now, what we're going to do with this is we are going we create what is effectively a blank blockchain, no transactions in it. We just create a balance in one account. Right. So I'm going to use a few of my libraries, which I say we'll share the links to.
What is the spec for the backend? Like proof of work, proof of authority,
Nothing.
the block time?
Nothing.
Nothing.
It's got a 10-second block time, but it starts at 0. It starts at time 0, which is kind of weird. Right. So first of all, we're gonna specify how much ether is going to be in a particular account. Is it going to be, what is it, str2 ether? Yes, here we go. String to ether. 10,000 ether. Just to make me happy. Yeah, I'm now rich. I'm going to retire. Another thing. Right, now I can just say base client equals backend dot new simulated backend and bracket core dot, thanks a lot. What is it? Genesis alloc. It gets a lot more fun in a minute, especially if you don't put too many G's in there. Genesis alloc. Right. We need the address of the person who's going to get it. Address. I don't want to get address. I want memory keys dot. I think that should work. Memory keys banker. Colon. Comma. There. Comma. Why the hell's that big? I can't even remember what that big number is. But it looks like 8 million. Oh! 4, 5, 6. Brackets. Then. Return. Right, if I'm insanely lucky. It doesn't like it, does it? What's wrong here? That goes. Oh, where did that bracket come from? Because there is no memory keys like that. It's all in lowercase. Memory keys. Now it imports memory keys. Get address banker. That probably doesn't work because get address requires an error. So banker, comma, under. That should work. No. There. Okay. Right. So I've got a module that I wrote called memory keys that just allows me to create as a map a whole load of key pairs, right? Private key stroke addresses and stuff. Right. So having done that, this should now create my simulated backend for me. Right. So now down here, I should just be able to say client ERR becomes equal to get client. Right. Just put.
That's how you catch the error.
Yeah. Yeah. Right. Now what am I going to do? What can I do with that? Oh, okay. Yeah. Okay. Now if we've done that, we can now see how much the banker's got. Val, comma ERR becomes equal to. In fact, why don't we just take this down here and be very naughty and have banker as a global variable. Ah, no, I can't. Damn it. No, can't do that. Sorry, I'm an idiot. Yeah, I need to put that in there because I'm going to have to do things with it in a bit. Okay, so we'll do it in here as well. Then I can just do. Oh yes, client dot balance at context dot background. Is it address? Yeah. Banker. Anything else we need? Yeah, no. What's wrong? Okay. I'm going to assume that is not going to fail. And then we put fmt dot print line ether utils dot ether to string. Bam. Right, let's see what happens if we run that. We're not dealing with the contract yet. Go on, work for me. Undefined memory cut. 15. What? Oh. No, because I didn't want that line at all. That's why. Tell me. There you go. So it's got my 10,000 ether in it. Thank God for that. Okay. Now we have got a blockchain. Yay. Let's see what we can do next. We have a contract. We can launch the contract, right? Now, in order to do that, we need something that can transact. We need something that encapsulates the private key. Yeah. So, banker tx, comma, memory keys dot get transactor banker. Right. That's complaining because we're not using it. Okay. Now I can launch the contract. How am I going to do that? Okay. Contracts dot new test banker tx. Probably it, is it? Okay, we need to oh, silly me. Deploy test. Now what's it complaining? Oh yeah, and the client. There we go.
So the deploy test here is the function inside the
the
wrapper.
It deploys that contract.
Yeah,
right?
that. But the function is coming from the ABIGEN, right?
Yes.
Okay.
Right. So if we look at this, now what the hell? I've forgotten what this creates. Test contract tx. Let's complain. None of that's used. Declared or not used. Yes. Yes. Now maybe I can. Okay. Test contract is an address. Thank you. Right. What's tx supposed to be? That's the transaction. Yes. This then obviously should be the test contract. Okay. Right. And then if ERR not equal to nil, log dot equal error. Oh, test contract address, isn't it? It's still not going to like it because I've got TX and test contract. What are we going to? Okay. In transaction. TX dot hash dot x. There. So now all I should have to do is to get rid of that for the moment. Then we should be able to run it again. Okay, so now it tells you that the contract was deployed at this address in this transaction. Yeah? Cool. We're doing all right, aren't we? We thought this would never fly. Power up on a bit more tea, and right now this was test contract.
Will it fail if the banker don't have any ether?
Yes. Oh yes. One thing about the simulated backend is that it will, if you do not have, hang on, if you don't have enough ether to pay fees, sorry, oh no, sorry, it does pass if you. There are times when it will just crash out, and that's it. I think that's if you let it try to determine how much gas it needs. If you say how much gas it needs, then it'll just fail. If I'm not mistaken. Right. Okay. So now we got test contract. Test contract dot. What was in there? My public variable, right? Right, now we are reading from the blockchain. So if you want to change the blockchain, you're submitting a transaction, you need a signed transaction, and therefore you need a key pair for it. To read from it, normally you don't need a signed transaction, and therefore you can just put nil here. Right, and then what was I looking at? My var, comma, error becomes equal to, we'll just steal that again. My var dot. That's not going to work. Will that work? Not sure. If I'm really lucky, it hasn't got a very. Why has it hasn't got my public variables? My public variable.
It's like cost out.
No. My public variable. 14 of them. What is that? Okay, that's a signature. Don't need that. Am I missing something stupid? Of course I am. What am I missing? Somebody give me a clue. What am I missing?
I think the client.
Oh, because it's not the test contract address, it's the test contract, isn't it, right? That's more like it. You can't. No contract code at given address. Why not? Oh, okay. And the reason is the contract hasn't been deployed. Even though it says it's deployed, it hasn't been deployed.
No, it's not mine yet.
Right? Because when you submit a transaction, it needs to be mined or sealed, depending upon the kind of blockchain you're on. And we haven't told it to do that. When you deploy a contract, you already know what address that contract is going to by a combination of the address that deploys it and the nonce. Nothing even to do with the code. So we know the address that it will end up at, if it ends up. Right, but okay. So what we need now is, because it's a simulated backend, we will just commit it.
What does
That basically tells it to seal a block.
Oh.
And now,
Without waiting.
yeah, right. And now that variable contains the number 0 because we haven't written a number to it. Are we doing well? I think so. Right. And now we're going to do test contract. What's the function called? It's called set my variable. Yay. Set my variable. Now, transaction operators, right? Well, we already created something up here called banker TX. I can just use that. Right? This is the transactor belonging to the banker. We can mess with it, but that will work. And we need to give it a new value, which we'll do big dot new int some totally arbitrary number like 42. Right? And this will again give you right, so we're going to do that, and we'll do I really need to sort this out. Never mind. Usually when I do this, I just create a function called check brackets error, just for demonstrations, because we all know we have to handle errors, but we don't have to handle errors when we're doing a demonstration, right? Until something goes wrong. Right, so now print line set var tx dot hash dot x. What doesn't it like? No new variables. Because we're just reusing them. Okay, fine. We're doing that. And then we're just going to do that again afterwards, right? And we will read it again. I might change var so I can assign a new variable. There's the new value. There's the old value. And if we're insanely lucky, we have to ask ourselves, why did that not work?
You need to commit the transaction.
That's probably a really good. Thank you very much. What an idiot I am. Again, you can get the transaction hash without doing it, because a transaction hash is just a hash of a transaction, right? Yes. Okay. Client dot commit. There we go. Now tell me what's wrong.
You're reading.
My change var error. That's probably a really good idea. Yes, let's do it before we read the bloody thing. Thank you very much.
Let's do. There you go. That's a 42.
Yay! Right. Time for a break.
Q&A maybe?
Hmm?
Maybe Q&A.
Okay.
Yeah.
So that was quite really whooshing through something. Why do I do this? That's probably the most important question. Because we know there are lots of testing tools around, right? There's Truffle, for example, that everybody loves doing Truffle. Everyone. Him. Right? But the thing about Truffle is that really you can only... it's a JavaScript thing. It's incredibly slow. And you test edge cases with Truffle. Right? You cannot do massive tests. You cannot stress test a contract. Stress testing a contract sounds a bit silly. But say you got you're doing some finance contract, right? and you want to, like there's interest rates and things like that. Say you put in an investment, you want to monitor that every day for the next 3 years. Do that in Truffle, and it's going to be incredibly slow. And if you want to do it for like 1,000 accounts with different values and have like different inputs and outputs during that time, in Truffle that will kill you because it's JavaScript chugging along at its own sweet pace, and even the code's going to kill you. Right? In there, using a Go simulated backend, it's insanely fast. Right? So, I mean, like, what we do at Hello Gold is we put gold on the blockchain. We put gold on and off the blockchain, right? And we have a gold token which accumulates fees at 2% per annum, calculated daily. And before we launched the token, I ran tests, doing snapshots every single day, and compared it with an Excel spreadsheet. Of course, we had a lot more accuracy than the spreadsheet, but we compared it with our calculations written in various languages, and we could prove that it worked. We also uncovered some bugs in it because we do certain things that require an awful lot of calculations. We do something every month where we allocate some gold to the holders of our other token, and it gets kind of complicated the way we do it because the old fees have to be taken off and all sorts of crazy stuff. And I then discovered that if we keep on doing it for the next 16.5 years, we would finally run out of gas in a single transaction. So I ended up having to do a second transaction. And then they raised the gas limit. And then E2 will be a lot, but who cares, right? So the point is, you can actually, you can do like massive bits of work, and it doesn't take very long to run. Right. Where were we?
Can you subscribe to events?
Of course, yes, you can. Yes, most certainly you can. And now I've got to try and remember how we do that. Yeah. And we're going to have to go into the Go thing because what's the event called here? It's called value set, right? Yeah.
What is event again?
Okay. Right. So again, if you don't know, what we've seen at the moment, we've seen two kinds of interacting with the contract, right? Apart from deploying it. The first one is where we change the value of the contract. We change the state. We're changing the state of the blockchain in general. So deploying it is also one of those, right? Now, and we had to wait for it to be committed, right? This is because on a blockchain, you create the transaction, you sign the transaction, and then you throw it up into the air, and one of the miners will catch it at some point, and you have no idea when, and they will include it into the blockchain, right? And there have been times when it took a couple of days for this to happen, depending upon the gas price you specify and all kinds of other things. So that is what we call a transaction. And if you look in the code, every time we do a transaction, I keep forgetting to do a commit, and then with the transaction doesn't happen, right? Because the commit simulates the transaction being mined. However, we also have this where I want to read the variable. And I do not need a transaction for that. And does anybody want to give me a good reason why?
What's the value don't do that? Global state.
Well, the contract's got a global state. I mean, that's why I'm reading it. But, no. The whole concept of a blockchain is consensus, right? So the consensus means that whatever your node thinks is the state of the contract, my node also thinks is the state of the contract. So we don't have to wait for any consensus for this, I can just look at my local node and say, hey, what's this value? Now, we have to be a bit careful here, because our nodes could be different, assuming that you just got the latest commit and I haven't. But generally, it's like when you look on Etherscan, it's the same thing. The only thing is that Etherscan tend to wait for a little bit before they check, right? So, all I have to do is look at my local node. I don't have to wait for consensus, and therefore I can get the answer immediately, right? So we do not need to wait for it to be committed in any way. Okay, so that's two things. Now we call that a call, right? I just call my thing and say, hey, excuse me, what's the value? As opposed to sending a transaction and waiting for that transaction to be mined. There is a third way of communicating with your contract. And that is that when you submit your transaction, we know your transaction gets recorded, right, in an immutable log of transactions, because the current state of your contract is the accumulation of one transaction piled on top of the next, right? It's like building a house full of Lego, right? And if you start up a node next week, you're going to follow the instructions and you're going to build the same house with the same Lego pieces, right? But you don't really want to start looking through every single transaction to find out what's gone on, because that's a lot of work. So what can also be done is that we put in an event. When an event is called, it doesn't alter the state of the contract. What it does is it takes a piece of information and it tags it to the transaction when it puts it into the block, and it creates what's called a Bloom filter, which is a way of putting information in that block so that you don't have to query the individual records. You can query the block and say, is there anything that matches this in that block, right? Which means that if I want to see, in this contract here, we had this thing called value set. I wouldn't have to look at all the transactions, all the blocks. I would just ask the blockchain, hey, find all the events on this contract that do this. Okay, let's see if we can do that. And this is where I'm going to make a big...
I have a question.
Yeah.
I know data type like integer or string. Actually, for blockchain is friendly to blockchain, but how about the array? So let's say I store array, some array element at block A, then some element at block C. Then how to
Okay, this is we're now talking about state storage, which for most people you can just regard it that your contract has got its own storage, right? And you can have arrays in there, you can have maps in there, right? You can have strings in there, and you can have most of the basic types. So, Solidity is very similar to JavaScript in a lot of ways. There are a lot of differences. There are a lot of things you have to be insanely cautious about. But if you think of it like that, if you think of it as having its own storage space, from a smart contract point of view, you're pretty much accurate. There are times when you can't do that, which, like when you're doing like really deep security audits, arrays can be very tricky, right? But let's not go there now, because I think that's way too deep, and I only know like maybe 2 or 3 people in KL who know anything about that, and I haven't gone there. Right, so let's look for that. This is what I want there, 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 there. What is it? Filter. No. Oh God. No. This is something I keep on doing this. I do it all the time, and occasionally I have to look it up. Oh, let's just try. Just for the fun of it. Okay, we're going to create a contracts dot new. It's not a new simulated backend. And what was it called? New value set filter, I think. Let's see. Undefined. Okay. Then we're gonna have to go in. New value. No. New. Oh, silly me. New test filterer. That's it. A new test filterer. Okay. There. Alright, now we'll see what we're missing. We are missing, what do we want? We want the address, which is test contract address and client. Right, and then we will steal that again. Usually I would have buckled and created a function for it a long time ago. But anyway, tf dot filter, what was it again? Set filter value set, I think. Does that work? Yes, it does. Amazing. Bind dot filter ops. Oh God. Is that right? Value set. There we go. A filter op. It's got a start and end. It's got a context. I think we can ignore all of that, and we just say filter becomes equal to, and then we can say typically in a function when you get an error you just return, and you let the error go up as far as you want it to go up. 4. Yeah, it's looking good, isn't it? Oh yes. Okay. This is a what? This is a test value set iterator. New test correct. Test value set event. Yes, an event. Okay. Yeah, an event. Main docker event dot. And what was it called? It was called new value. We will print that. Print line ether utils dot ether to string. See what we get with that. It's a 1,000,000 to 1 chance, but it might work. It didn't like me. Tilt camera. Of course, yes. Yes. Okay. Now I set the value to 42, and I'm reading it as if it was ether, which it isn't. Never mind. Now, in order for this to make any sense at all, it would probably be really good if we actually did that a couple of times. So where are we? We set 42. Okay, quick. This is how I do my magic trick. Somebody give me a number. A number.
55.
55. A number.
48.
48. And 13. Unlucky for some, carriage return to others. Okay, let's see what happens. 42, 55, 48, 13. Right? So after the event, I'm going in. Right? Now, you also notice what I did in there was that I included several transactions now before the commit. You don't have to have one commit per transaction. Now, I actually don't like that. Let's do. That should give me the numbers on their own. There we go. We can also have the date tags. The date tags will all be the same because it was all in one block, right? But anyway, we can still do it.
Yeah. You can do multiple commits.
Yeah, we'll do that afterwards. Date.event. And what do we call it? Something exciting like date, possibly. Because it's a big int, we have to convert it to a string. 20. It's all in block 20. The first block, because like what it does, it just increments the block time by 10 each time you commit. Right, of course we could have said to ourselves, we want to commit there. In which case, when we do it, we get 20 and 30. Yay! Aren't we doing well? Oh my God, that's about it, isn't it? Really? Of course, we could turn around to ourselves and say, well, actually, I'd like it to be a bit more realistic, because I don't think that I really want my blockchain starting at time 20, because the block timestamp should really be a time. And I only mention this because I like to. Client dot adjust time. Oh God. How to do that? What we're going to have to do is we're going to have to go into there, go for the epoch converter there, and we'll start it with now. Yeah. There we go. I think I can do that. Right, and then we'll do a client dot commit. We'll see if that works. It's a 1,000,000 to 1 chance, but it might work. It seems to. No, it didn't.
So, otherwise, do you need to adapt the Jensen work?
No. You can adjust the time as soon as you've got your client. Okay. What I'm going to do instead of this is I'm going to do that times time dot second. Try that. There we go. Right, now the interesting thing about that is now in here you can say time, say tm becomes equal to time dot unix brackets date dot, we need that because that's going to be a big int, so we'll just do a uint64 should work, comma 0, and then we can put tm there, and it's not going to work, but I'll find out why it doesn't work when we try and compile it. Type func, oh silly me. No. 64. The joys of a typed language, which are a lot more than the joys of an untyped language. There you go. It gives you the time that the blocks were committed. Not real time, of course, because it's a simulated backend. But this would allow you to. The adjust time function that I was demonstrating would allow you, for example, to have contracts that would allow things during certain times, and you can test against times. I mean, the first thing we ever did that with was ICOs, but I also used the same concept for testing throughout, testing interest rates and things like that. What else is there really? There's a lot, but I mean.
So you can do multiple time jumps in one.
Oh yeah.
Part.
Oh yeah. I mean, yeah. You want to do that? No problemo. Right. This tells you how many seconds to go forward. So you cannot go. Okay. You can't go ahead of the current time, right? So let's be careful with that. Where's my 55s? Client commit there, right? So instead of that, we're going to do this, and we'll just say 1,000, right? 1,000. How many seconds in a day?
86400.
Huh?
86400.
Damn it, you're good. 86400, right? That should work. Actually, I could just put time.day, couldn't I? It'd be a lot simpler. Never mind. Here we go. Now when we run it, it says, oh. Invalid receipt root hash. What? What doesn't it like? Simulate backend, ABI by simulated go, main.go 66, which is. Okay. Where was my initial time?
It is expected, isn't it?
Huh?
Because you're going back in time.
Why am I going back in time? No, this is a just time forward. It always goes forward.
Oh, just time is taking you from the current
Time forwards, yes.
Oh, supply. I see.
Yeah. So why doesn't it like that? So what does it say? Invalid receipt root hash. I've never seen that happen before. Right, adjust time there. Let's just see what happens if we do the fork. Does it still not like it? Still doesn't like it, does it? Be strange. Or have I just broken something in general? No, it's okay. Very, very odd. Not sure why. Considering the fact I've done it all over the place.
Can you copy value on top and just add 1 and
Can I do what?
can you go back to the first jump on the top?
Yeah.
Can you copy that value 14 something just now?
This?
Yeah, copy that
Yeah.
and put at the line that you just commented out just now.
Yeah, but I mean, that ain't how it works, trust me. because when I first proposed this function, I called it jump forward in time, which was totally weird.
Try to put 1.
Like that.
Yeah.
Oh, so you've gone into the future.
Same.
Same thing. Okay, so I'm really not quite... Oh, here you go. This is a future block timestamp. This is different, right?
Panic.
Greater than allowed that much. Okay. Take that much.
-1.
Put 1 on there instead. Let's see what happens. It's a 1,000,000 to 1 chance, but it might be... No?
Panic from the past.
Oh, this is kind of weird.
Still future.
Hang on, is this still a... Hang on. Let's see where I started running. Oh, no. Okay, let's just say 200, right? Let it panic for some totally different reason. Now it's panicking for a completely different reason. Invalid root hash. I've got no idea why an invalid receipt root hash. I ain't going to debug this now. Too much of a headache. Of course, we can just do 2 commits, but no, not even that. Interesting. Right. So what we've demonstrated here in this insanely simple piece of code, I mean, yeah, it is. It's actually a very short piece of code. We created like a mythical blockchain. We deployed a contract onto that blockchain. We read values from that contract. We write values to that contract. And we look for events, which is all the major ways you can interact with the contract. We didn't send ether to it. There are 2 different ways you can do that, but let's not worry about that.
Rather than Go, it's C++ and Python.
You can use Python. Then you use Web3.
Okay.
Again, you won't get the speed. Right?
Even comparing to Rust, still Go the best.
No, Rust is faster than Go.
Okay.
Go is a lot more readable than Rust. Right? The Go version, the Go client is the reference client.
Yeah.
And then like the parity team then look at the Go code, and they then implement their stuff in it. So, yeah, because Rust is quite a bit more complicated. Right. Any other questions? No, simulated backend is part of the Go Ethereum client. I built a few things that I use to complement that. So like ether utils is just like Mickey Mouse stuff. It converts, the 18 decimal point numbers to numbers with decimal points when you're dealing with ether and things like that, or for not 18 point if you're dealing with like tokens with different decimal places. Memory keys was something specifically for testing, because every time I run it, like the banker address is going to be different in this case, because it's just created in memory. One of the articles on Curry describes how that is done. But in this case, that's the only stuff that I did, apart from wrote the adjust time bit, which is claim to fame. Not a very good claim to fame, but it's a claim to fame. Yeah. There we go. Any more questions on that? Otherwise, I mean, we can do all kinds of things. We can mess with the contract. We can go in any direction you'd like to go. Now we've got the basic stuff.
I try to understand like difference between Go, Backend, and if we try to code it in Java.
Java or JavaScript?
Java.
In Java?
Yeah.
Okay.
Because I understand that EVM is something like JVM, right?
No,
So
no. Right. So the Go virtual machine, right, is okay. I mean, it's a virtual machine, right? The virtual machine can be written in any language you like. So when you're using Remix or using Truffle, usually you work with a JavaScript implementation of the virtual machine, right? There is, I think it's called Harmony, a virtual machine. Basically, there's an Ethereum client written in Java, which means it implements a virtual machine written in Java, right? If you're running Parity, you've got a virtual machine that's written in Rust, right? The main thing is that when you compile Solidity code, it compiles down to bytecode, right? Now, in the past, you may have come across this with .NET. So .NET allowed various languages to compile down to a bytecode. The first one that I ever knew about was UCSD Pascal, where that compiled down to what was called P code. What that meant was that what it means is that as long as you can implement something that will create the imaginary world of a machine and execute the instructions in exactly the same way that all the other ones do. So you get an add instruction that adds two 256-bit words, but you end up with the same result that everybody else does, right? So it can be written in anything you like, right? That's the VM. Yeah. Right. But you can there are clients written in different languages. Not so many on the Ethereum mainnet at the moment with ETH 1.0. ETH 2.0, there are a lot of them. Enterprise Ethereum Alliance have got a wide range of them. They particularly were interested in Java because a lot of the high-speed banking applications are written in Java. So I've got no idea why you should be so concerned about the client being written in that. But anyway,
developers on board.
yeah, possibly. But I mean, the main thing is that I have been dealing with things in two different areas here, right? I have dealt with writing a smart contract, which you could equally interact with from Etherscan, right? So, taking what Zul was saying, if I were just to take this contract here, right, and put it onto a test net. Let's find a version of Remix somewhere. Use previous version, like everybody else. I can't be asked to mess with the new version. Right.
Can you zoom?
Yeah, give me a sec. Let's just create a new one. This is fkl.sol. I probably can't zoom as much. I'll just paste the code in and then we'll see where we can zoom to. There we go.
Okay.
Yeah? So, if I put this here and I take my MetaMask and say we will work on the Kovan test network, right? Just because it's there, right? Now, we compile it, it compiles. We can deploy it, In which case MetaMask is going to come up and say, do you want to do this? And I'm going to say, yeah, sure. And we wait because it's going to be mined this time. Or actually no, because it's a proof of authority network, so it's not going to be mined, it's going to be sealed by one of the clients in turn, and they just check each other. And you will see that down here we have got my public variable, which is currently 0, or we can set it with a value, right? I did not have to do anything apart from just click to check the public variable. We are working on a blockchain, right? And you can prove that we're working on a blockchain just by copying that address. We can go to kovan.etherscan.io. We can look at that address. We can see that 49 seconds ago this contract was created. We can, silly me, we can look at the contract. We can even verify the code. Whoopee. Contract address we'd like. Compiler type is Solidity single file. Compiler version was 6, if I'm not mistaken. Open source, no license. Continue. And where's it gone? I've lost it. There. Right, we go back to there. Put that in there. Optimization is probably yes, because I normally have optimization turned on. Right, here we go. And technically that's true. Okay, and we can verify it. Yes. Right, so now it has been verified. We can go back, and Ethercan now declare to the world that they have checked that this source code actually does give that code on the blockchain. And we can look at it under read contract. We see my public variable, which is 0. Using Etherscan just for the heck of it. Yeah, okay, fine. I can give it a new value. So we started off with 42, did we not? Right. Confirm. View your transaction. We're waiting for it to be sealed on the blockchain. And we will wait, because when it arrives, it'll be fun.
While waiting, maybe you can explain to them about the scan via background.
Okay, of course. Yes, so you may be aware that Hello Gold, that's us guys, are one of the 2 sponsors of FKL. Etherscan are the other one. So one of the first bits of pride I had was discovering that Etherscan is actually a Malaysian company based in KL. Yay! Right?
Wow.
Yes. Right. So it's really like discovering the Google of Ethereum is based right next door to you. So Etherscan, right? Basically deploy block explorers on most of the test nets. All of the test nets? Yeah. All of the test nets. There are a number of different side nets they don't support. Okay, here we go. So it has succeeded. Yay. I don't know what state changes does. I have never checked that.
They tell you how much you spend, what is the balance before and after, something like that.
That's not quite what I was after. I was after this. This is the okay, you can view that as a number. 42 is my new number. And this was the timestamp, which, had I kept the epoch converter open, you could paste that into there, right, which was 2 minutes ago. Right. So it gives you the this is the event. So that's what I'm telling you, that the log information is stored with the transaction, at least for some time. There's no guarantee how long it will be there, but so far it's back to the beginning of time. Right, so what we got is got a timestamp. It's included in a block. This is who it's from. It went to this contract. You can click on more. You can see it says set my variable. Right now, this is the encoding of 42 in 256-bit format. This is like the truncation of a hash. Right? So what happens is it takes the signature that you can see up here, set my variable, just followed by uint256, ignores the name, right? And it hashes that, and it takes the first 4 bytes of that. And the smart contract, when it's compiled, uses that hash to determine to call this function or another one. Oops, pardon me. Sorry, can I call you back in a bit? Thanks. Right, so that is how, when you send a transaction to a smart contract, you're telling the smart contract which function to execute. It does mean it's possible to create 2 functions with the same signature, in which case you can mess things up.
Assuming I'm not using either scan, how do I know what is the signature of my function? Can you demo that?
Yeah. In here, somewhere in here, it told you these are the two functions.
What if I don't have Go and
Right.
ABIGEN file?
Or if you go into Remix, yay, you can look at the details, right? And it tells you somewhere in here exactly the same thing, right? Right now, the ABI, this thing is just this. The ABI is a way that describes the interface to your smart contract. If you're using JavaScript, you use the ABI. If I copy this, I could, for example, go to crypto.com. Right. And how are we going to do this? We're going to use MetaMask. Yeah, connect. That's really stupid because I wanted to interact with the contract. I would paste in the ABI there.
You need to change the network.
I probably do. I think I can do that afterwards, can't I? I hope so. Right, I can put in the contract address there. Notice the web's crazy. Change the network to Kovan. Paste the address back in again. Access it. I can have a look at my public variable. I can read it, and it comes back as 42. Or I can set my variable, and I can put 1024. For example, you've lost. Yeah, right. Right now, I have to use MetaMask to do that, and I can new value 1024, and the value is 0. You're not going to send any ether with it. No, it's all on. So generate transaction, send transaction from testnet transaction, thank heavens. Do that. Confirm. We can verify that transaction took place. It's already been included, which means that if I come back to here, go to the run page where this existed, I can check my variable.
Yeah, 42.
It says 42, doesn't it?
Wow, okay.
Why does it say 42? No, 1024. Okay, sorry, just updated. Silly me. Which is an interesting question. Another interesting question. Why did it get the wrong value? Blockchains, right?
Yeah.
Consensus, yes? And I did say that, my version of the blockchain and your version of the blockchain might be slightly different. So, like, Etherscan could say it's in, but MetaMask could say, I want to wait a bit longer before I accept that block. Right? Because the way a blockchain works is that miners keep adding blocks, and so like two different miners can create two different candidate chains, right? And and like each of those miners they're dissipating their candidate chain amongst everybody, right? And then when it reaches someone, any individual that has both of them, they decide which one they want, and they do that based upon which one is longest, right? Which one has most blocks in it. So it is possible temporarily for you to think that this is the state of the blockchain, and then a short while later you change your mind. Now, in order for you to be able to deal with this in a sane way and not have to roll back your view of the universe, what most people do is they wait for a certain number of blocks before they look at this block. In other words, if there are 10,000 blocks in the blockchain, I will look at 9,980 of them, and I'll stay 20 blocks behind what they call the tip of the chain. Right? And then, as I get past that point, I will then look back from whatever I decide my arbitrary distance from the head is to when that transaction was committed. And I will say I have that number of blocks confirmation. So on Etherscan, when it says you've got 20 confirmations, it's not talking about 20 people agreeing. It means that from the point that Etherscan think that the network, that the chain is solid, this transaction was submitted 20 blocks before that, and then for each block that confirmation count will go on.
Does that offset actually depend on the number of nodes in the network?
No, it's what's the word? It's a bit of prudence, really. I mean, there is some science behind it. It's more upon the number of nodes that would agree with it, but you can't tell how many nodes agree with it, right? All you can do. So, like, because you can model the state of the network, assuming that there's nothing disastrous about the network, you will reach consensus, right? So you can do statistically how many loose blocks are there likely to be in disagreement between two chains. And of course, if there are clients with bugs in them, then you could have no convergence. Right?
Like clients.
So say you've got client A, and client A it interprets transactions, or the EVM has got something. Maybe there was lack of clarity in the specification of a change, right? So a new client comes out. This guy, client A, thinks that this is the view of what this transaction should do. Client B thinks something else should happen. Right? Then if I give you one of mine, you're going to reject it because it doesn't agree with you. Right? Then we get what's known as a fork. Right? That there are two chains which are growing ever longer, but you will never see the new blocks on my chain, and I'll never see the new blocks on your chain. Right? That's what a fork is. Right? And of course, at various times, blockchains have forks. Right? So, right, Ethereum Classic forked because they had a disagreement. So actually, at that point, the Ethereum devs put a flag in the Ethereum client and said, as a miner, you decide which chain you want to follow by setting this flag. Right? And it was basically a miner vote. The same thing happened with Bitcoin when you had Bitcoin Cash and the Bitcoin or all these other things. Right, these are called hard forks. Right, a soft fork is when it's sort of like the previous case when it will come back together again.
But it's not something like this can happen, for example, because you different nodes from different versions of Ethereum.
Yeah. Well, not necessarily different, not different versions of the EVM. That's very unlikely. Because basically nobody should be running bleeding edge, EVM code that the old clients can't detect until you got far enough back for everybody to upgrade the clients. It would normally only happen, one, because of a bug, and the Stellar network in 2014, I think it was, had a fork that was due to a bug, that different versions of the client actually gave different results, and so on. As I said, quite often they're deliberate. Most hard forks, actually, one of the two branches dies immediately. Right? So this would happen, for example, like on Ethereum you have like the Istanbul hard fork. Before that you had Constantinople, where you're bringing in a new set of features, and it's agreed by everybody that these features are desired. So everybody switches their clients over as quickly as possible, and so that other possible alternative being is abandoned immediately.
Or they upgrade, or they just get left behind.
Yeah.
Completely useless.
Yeah. I mean, typically you'll get people sending messages on Twitter and Reddit and everything else saying miners, if you're still running this, well, not just miners, because remember, you don't have to be a miner to be running a node. Right? You can be running a node on your notebook. That just allows you to submit your transactions faster, right? Or you can have a big machine, whatever you want, just to allow you to get your transactions onto the network. You can be running a light client. Well, light clients don't really do the same thing. They just pull the state from the main node. But yeah.
Okay, then once we have one contract, like having my variable, something like that, then later on you want to amend.
You cannot change a smart contract.
Yeah.
Right?
Is it like I have to create a new one and then turn off the old one, or how?
How do you turn off a smart contract? You can self-destruct. You can basically self-destruct or destroy a smart contract if you build in the capability to do so. It hasn't been terribly popular since sometime in 2017 when they didn't do the security right, and one of the parity wallets got destroyed and lost a few thousand ether. people tend not to do it, right? But you can do, because it's a programming language, you can do what you want to do with it. Right? So it is possible to make an upgradable contract where where the front end contract just passes the calls onto a back end. The back end executes it within the data space of the front end contract. And you can then, if you need to, you can change which back end contract you use. So you would upgrade it by passing it on to a different back end contract. Right? And we did a little bit of work on this before. Right? So, I mean, the whole point is that in no way is a blockchain an answer to everything. A blockchain it's only a piece of software. It's a new software tool, just like a database is a software tool. But it's what you do with it. It's how you use it. So, you could write a contract where one person could change all the data, right? You could remodel a bank where the bank manager can just take money out of your account. I don't think many people would use it, right? Because the selling point of your blockchain should be the immutable record, the fact that you can trace through all the records, or let's say auditable records, and the fact that you can see the code in the contract. So as long as you understand how the code is going to work, you can trust it to work like that. Right? So this allows you to build systems which are predictable. So it would allow me to interact with you without having to trust you, and you don't have to trust me, because the contract will make sure the contract will follow what it's supposed to do. Right? So a distributed exchange is exactly that. You put tokens in, I put tokens in, we agree on the exchange rate, and then either of us can activate it once we've agreed on everything. Or I make an offer and anybody can accept that offer, but they have to fulfill whatever I stipulated to be the terms of my offer, and then that can be executed. I mean, that's part of the power of blockchain is, and already we have seen some very powerful systems being built. We've also seen some rubbish being built. We've seen scams being built. You can still build anything you want on top of it, right? It's not an answer to everything, but over time, hopefully, we're learning to build better things on top of it. Right? There are lots of problems to solve, right? Like making it usable, making it easy to send transactions, because not everybody likes logging in with a hardware wallet. Right?
Question.
Yo.
From Nick Johnson, the writer or the starter of the ENS contract, he mentioned that he wrote the contract using LLL. Do you have any clue why LLL instead of Solidity? Have you wrote anything using that?
No, I didn't. I looked at it, and to be honest, I can't even remember what it stands for. Originally, people said it was low-level language, but then other people say no, it's not.
Okay.
I think they came up with another name for it. I think sufficiency. I think.
Right.
It is closer to the metal than Solidity is, so you don't get the same overhead. So why particularly they want it?
But it still produces the same bytecode as we use Solidity, right?
No. It still compiles down to the same EVM code, right? But it can't compile down to the same bytecode because you don't start off with the same instructions, but it allows you to tweak things better. Right? No, it's just like using. I mean, it's like you can use assembly language versus C versus JavaScript. Well, not versus JavaScript. That doesn't count. Versus Go versus Rust. They all end up compiling to machine code, right? Some of them give you more control.
So the bytecode itself is still not the final.
No, as far as the EVM is concerned, the bytecode is as low as you get because you're running on other people's nodes, right? So the bytecode is like assembly language. It's the assembly language for the EVM, if you like. LLL is, as far as I know, it's a less rich language, but it's closer to the bytecode level. So you have to be a lot more, as far as I know, you have to be a lot more careful writing it because you can make more mistakes, right? But it doesn't put in things which will protect you, for example. So for example, that Solidity will revert if you do certain things. I may be wrong, as I said, because I've never looked at LLL, but there may well be times when LLL would let you do something that Solidity protects you from, right? But by taking out that protection, it makes that function run faster. Right? So, it's like the protections are great. You don't always need them.
Are you saying that the try cache part is not built in the EVM, but built in on the abstraction layer?
Some of it maybe.
Okay.
I'm not sure, right? But I mean there will be a number of things. It could also just be like the way variable space is handled, for example. Right? Because what the compiler does is it says, given this instruction, how are we going to do that? Right? It's like, the high-level language says go to the airport. Now you can go by train, you can go by bus, right? I could also tell you, okay, walk to the door, open the door, walk out into the lobby, press the lift button, go down. I can give you far more detailed instructions, right? I'm still not giving it to you in like the lowest level, because the lowest level tells you what impulses to send to all your muscles and everything else, right? But I can actually give you different, right? And the broader the brushstrokes, the less control I have, right? If I just say go to the airport, I haven't even told you what time you've got to be there, right? So you could walk, or get into the river and swim, or whatever you want to do, you get my point.
Yeah.
Any more? Are we having fun yet? I will put a link to, right, when we do release the video, we are going to release the video.
Yeah.
You fools. When we release the video, I'll put links in there to the articles. There's a set of 4 articles so far that explain it. And I'll watch the video so I can do the next article on events. And also links to the libraries.
The code.
Yeah, the code. Yeah, we'll put the code somewhere as well.
Okay.
Not that there's much of it, but yeah.
Any requests from you guys? What topics that you want to learn in the next meetup? Do you have any requests? You can tell us now so that we can prepare the content. This is the first one. No, this is not the first one. We have been doing this for.
I guess two more sessions, yeah.
But for the developers track, we just started this year. Oh, yeah. Before this, just that track.
Yeah.
I guess this is the second for developers.
Developers, I think
I think it's the third.
I think this one is the third.
Yeah. I did one going through the DevCon option contracts.
It's just
Caleb did one.
I want to know the technologies we are going to use here, and I'm because I don't know I don't know Go.
Okay.
Solidity is close to
okay.
JavaScript, so
Well, Solidity is the thing that we're going to pretty much have to do. That I mean, in terms of talking to the EVM, there are a number of options. There's Viper, which is a bit like Python. There's LLL, which is a bit like something or other, I'm not sure what. Solidity is the most popular. And that will cover a lot of your use cases, right?
yeah.
Now, the next thing is, how do you as an individual talk to your smart contracts? Well, I have just illustrated that I can talk to the smart contract
Using Go.
using
Go Ethereum.
Remix,
Oh yeah.
using my crypto, right? I can also do it from Etherscan. If we have a look on Etherscan, where is it in here? Where did I? Okay, yeah, I can. I did the first write in there, and I can check the current value, which probably needs to be refreshed. Right, it's now 1024. I can use Ether. Right, there are lots of different ways you can talk to your contract, and we did something in Go. Far more popular is using JavaScript. Right, and the reason for that is, as I've said, if I were to write a website where, I ask you to give me your private key, and I then send it back to the server, and I do the signing on the server and send off the transaction, you don't know what the hell I'm doing.
Yeah.
Right? And say you've got 100 Ether sitting in your account, are you going to give me your private key? No way. Right?
Yeah.
In fact, far more to the point, if you've got 100 Ether, hopefully you don't even know your private key. Hopefully it's inside a hardware wallet which does all the signing inside the hardware wallet, right? So that nobody can get the worst anybody could do would be to trick you into signing a transaction, right? And then, so the whole idea of using Go is not for everything. Right? It's only for, in fact, it's kind of like a set of niche cases. Firstly, the test environment. Secondly, like oracles. So as you know, we deal in gold, so we could put up an exchange allowing people to send Ether and buy gold tokens, in which case we would need to tell the contract what is the price of Ether, what is the price of gold.
Okay.
Right? So that we can have a contract do that calculation. Now, in order to do that, we're taking something from the real world and putting it on chain, right? And we can write something in Go that does that. That we can run a little daemon that goes out every 5 minutes and it picks up exchange rates, it picks up gold prices, picks up Ether prices, and it pushes it all in and does some magic, right? Far more common is my crypto. Is Etherscan, is all kinds of things, Uniswap, KyberSwap, a whole load of contracts that allow you to interact with the blockchain, right, from your browser. And they are all written in JavaScript for the very simple reason that you want to be able, if you have the capability, to look at the code and to be sure that it's not abusing your private key. Right?
Can I add something just to clarify? The signing part can be done anywhere. Can be done in front end, back end, doesn't matter. That's why we have Web3. When you sign the transaction in the browser itself, you are not giving the developers of the website your private key, but
Private key.
Using your private key to sign the transaction straight away.
In fact, you shouldn't even sign it on the website at all.
Yes.
You should sign it off the website. Right? So MetaMask, for example, abstracts that away. It injects Web3 into the web page, but you have to authorize MetaMask to talk to the web page, and all of the signing takes place inside MetaMask. Right, and so when you click your confirmation, so as you saw here, when I write my new value to this, which is say 365, and I click write, connect to Web3, yeah, okay, fine. Okay, I now click write, right? Now, when this window comes up from MetaMask, I can see that it's not sending any Ether.
MetaMask is a wallet.
MetaMask is a wallet implemented as an extension to the browser. Right?
Oh, so it's still off the browser.
Yeah, so the web page itself cannot see into MetaMask. Right? Right, so I do that, and at some point that will get changed, and we don't really care about that. Now, other ways of doing it are using, for example, hardware wallets like. Oh my God, what's he got in here? Oh, bloody hell. Not that. Somewhere I have a hardware wallet. I seem to have lost it again.
Definitely, this is something I don't want to hear.
I have the backup phrase in half a dozen different locations. I can recover it. Here we go. The little bag of tricks, right? So these are banking hardware keys. These are crypto hardware keys. This is a Ledger Nano, right? Which its one job in life is to maintain private keys and to sign transactions, and it can do it in various different formats. So you can do Bitcoin, you can use Bitcoin with it, you can use whatever. But all it does is sign transactions. It does not know what your balance is. It doesn't understand a balance. Right? Right. That is a hardware key. Right? It can sign transactions. You can't get the private key off it. There we go.
Any requests from you guys for the next one?
Shall we?
Yeah, we'll end.
Yeah,
Put on.
Yeah.
Yeah?
personally, I think it would be nice to, for example, see what our